Hi, it's Mr. Anderson, and this is a beginner's guide to graphing data. I continue to be surprised by the simple mistakes that are made by students in my high school science class when they try to display their data in a graph. And I think the reason why is that we spend a lot of time in elementary school on graphing, but as students move from middle school to high school and on to college, we don't spend very much time on graphing. It's just like reading. We assume that they know how to do it. And so I've put this video together to show you the importance of graphs, the different types of graphs, and even give you some practice graphing some data. And so first of all, let's start with the term graph. The term graph and the term chart can be used interchangeably. They mean essentially the same thing. And so you'll hear me go back and forth between chart, graph, plot. They're basically ways that we can take data and display it visually. And so why do we use them? Well, let me give you an example. This right here is Charles David Keeling. He spent years and years and years on top of Mauna Loa in Hawaii collecting data on the levels of carbon dioxide in the atmosphere. And let me show you less than 1% of the data that he collected. It's almost incomprehensible to us. When we get a huge list of numbers, we can't make sense of it and we can't find patterns. But if I were to show you all the data that Mr. Keeling collected, we would find the Keeling Curve. And this is one of the most famous graphs in all of science. It's basically showing increasing levels of carbon dioxide. You see annual cycling of carbon dioxide. And this is very important because it's tied to global warming. And so when we can see the data, we can make sense of the data. And so there are 5 major types of graphs that I'm going to talk about in this video. They are line, scatter, bar, histogram, and pie graph. And so I want to start with a little pre-quiz and see what you know. And so could you right now point to the line graph on the right? Let me show you if you're right. Line graph is going to be that one. Could you point to the scatter plot now? And what about a bar graph? Could you point to the bar graph? And the histogram? And hopefully you can point to then the pie graph. Okay. So how did you do? Did you get all those right? Hopefully. The ones that are confusing, obviously a line graph is going to be dots connected with a line. Even though we have a best fit line here, the scatter plot is not going to connect the dots at all. It's going to show correlation between number sets. Did you get screwed up on the bar graph? How do we tell the difference between a bar graph and a histogram? Bar graph, we're going to have space between the different columns. In a histogram, they're going to touch. And so the reason it's important that you know and can identify the different graph types is that as a scientist, you're going to collect data, and then you're going to have to choose what graph you're going to use. In other words, the data always comes first, and then you've got to figure out what graph you're going to use. And so let's talk about 5 different types of graphs. First one is going to be a line graph. We're going to use a line graph if we're looking at change over time. And so in this one, we're looking at U.S. trade in goods and services. And so you can see that the dates are going to be along the x-axis, and then the monies are going to be along the y-axis. And so in science, maybe we're collecting data on an individual worm and how much oxygen it respires over time, or it consumes over time. Then a line graph would be a great example. Let's say we're looking at a scatter plot. We're going to use that when we're correlating 2 number sets or 2 sets of data. So it's a correlation of variables. And so this scatter plot right here, they're looking at the eruption of Old Faithful, how long that eruption takes, and then the time between the eruptions. And you can see that there's a relationship between those two. Scatter plots are really important in a science classroom. Forever varying one variable, we call that the independent variable, and then measuring how that affects another variable, we call that the dependent variable, then a scatter plot is going to be the graph of choice. And so when you're doing that, make sure that you put the independent variable on the x-axis. And so let's say that this plant right here, I'm doing an experiment where I vary the amount of fertilizer, and then I measure how much that plant grows over time. Well, since I'm varying the independent variable, I'm going to put that on the x, the amount of fertilizer, and then we put plant growth on the y. And we look at a correlation between those two. So scatter plots are incredibly important in a science room.